Hello and welcome back. In the previous lecture, we understood how map transformation is working. To extend our same discussion, we are going to revisit the filter transformation. We will also going to implement the filter transformation in our local IDE, and I will try to explain how filter transformation will work. Now with the same pattern, let's understand. We have called an RDD X where X is containing three different elements. Filter operation will look at each of the element present onto RDD X and will try to apply the filter logic which you have written. If the logic is written true, the element will be carry forwarded to a new RDD, and if the object is returning false, that element will be discarded. Let's say the second element, let's say the first element written true, so it got added to RDDY. Now going forward, let's say second element which is not fit into the condition which we written into the filter operation, it returned false, so it will be get eliminated and not getting added to RDDY. Now coming to the third element which is again returning true, so that element got added into the new RDD which is RDDY. As filter is a transformation, the output of the filter transformation will again be a new RDD or a data frame. Now let's look at the before and after RDD. The first RDD X has three elements, but the new RDD which is RDDY has only two elements, as the middle element did not return true and did not succeeded to the logic which we implemented. If we look at the code, let's keep it simple and try to understand that. Again, we have two separate code block here. One is written into Python and one is in the Scala. What we are specifically trying to do here is, we are trying to check what are odd values we have in our RDD. So first we created an RDD with element called 1, 2 and 3, and then on the RDD we are specifically applying the filter transformation. In the filter transformation, we are writing the logic to say that whenever the element we read, if the modulo is 1, then consider it into a new RDD, and if it is not, then discard it. So the resultant RDD which is Y has only 1 and 3 as a result, because the element 2 has no modulo called 1. Same way, we replicated the same piece of code in Scala, which is just below that code. Now let's try to look at the filter operation by visiting our IDE as usual. We are in the program. As you can see, as usual, we read the CSV file and created a data frame. The first operation is happening, the df.show will eventually give you the first 20 rows. Then we are applying a filter operation. Where we are applying the filter operation? We are applying the filter operation on top of the data frame which we have created. And then we are writing a logic that what kind of an filtration we want to do. So what we are saying is that Spark, please return me those kind of an job roles which contains a serial, which is a senior dominations for each of the role, and then I'm performing an action. So I'm explicitly asking Spark to only return me those kind of an job role which contains a senior in that keyword or in that role name. Let's execute and see the difference. The first what we are doing is we are printing it as in 20 by default, and then the data frame is applied, the filter is applied on top of the data frame. Let's execute and see the difference. Here we have our output. Let me expand this, and now as you can see, the first output which is here is the resultant output of df.show, whereas in case of, you can see the second output is the resultant output of what we have printed into the filter operation. As you can see, in job roles, all the roles are containing serial only. So whatever role is having the serial into that keyword or in the role name, only those are fetched. and all the objects which are written, which is our new RDD formed from the filter, has the senior in the keyword or in the role name. Let's revisit couple of other things as well. Let's try to perform a count operation, and that way you will be much more clear that how many records got filtered out. To perform a count operation, I will simply try print df.count, which is the first one, the count operation on top of the data frame, and then I will try to perform a new count operation on the new filter operation. So here I am removing the show method for now, and let's create a new filter new filtered data frame. And I will try to perform a count operation on top of it. We'll see how the difference look like. Let me comment this out. Now let's execute the code and we'll see what is the difference. We have the result. The file is containing 12,000 records. As we have counted on the top of the data frame, it gives us 12,000 as an output. But when we perform a filter operation where we are saying just give me those job roles which contains a senior as a keyword into it, which resulted us into 561. So that way you must be now be able to understand how filter operations are working. Let's visit the definition again. Filter operations are those operations which will filter out your raw or your inputted RDD to a new RDD where you want to perform a specific logic on the basis of true or false. I do have a couple of more examples as well. Let's revisit them one by one. To the first example, let's try to see what we are trying to do here. Let me remove this one as well. What I'm specifically doing here is I'm trying to convert the data frame filter, and then I'm trying to apply and say specifically saying that Spark, please return me those columns which has the value as in senior data scientist. I don't want any other roles or any other type of data job roles. I am only interested in the senior data scientist roles, and then I'm saying so as in truncate false. By doing so, you will see the text is in complete full length. Now to make you understand one more thing, when you perform a data frame, you can use any of the column or try to see the data of that column from the data frame by applying a call method. Now when you say call is a function from the PySpark SQL.functions method. So you need to import this module to use the column functions out of it. So again, what I'm doing is I'm asking Spark to filter out me those columns where job role is equal to senior data scientist. You can see this as a query as well. Yes, of course, you can write a specific query like select star from table where job role is equal to senior data scientist, and you can perform the exam. But that is not the scope of this specific module. We are definitely going to cover that when we are going to look at the Spark SQL module. So here in the data frame we are doing so operation, and let's try to execute that and see how it looks like. Here is our output. As you can see, Spark has extensively written us those roles only where the job role is senior data scientist, and it written all the related records along with that, which company, where is the location, what the job experience needed, and what all skill sets we have, right? So this way you can specifically filter out on a column by saying only return me this specific keyword of the column. Now if you remember, when we were revisiting the data frame, I mentioned specifically that data frame is very much closely related to an SQLs. You can perform all the operations which you used to do in SQL using the data frame. Let me quickly take you through that piece of slide where we visited that in past. Remembering this slide, here the first point says a data frame is a programming abstraction in the Spark SQL module. Data frame resemble relational database tables or Excel spreadsheets with header. The data resides in row and columnar of different data types. So it is very much in relation of database. Let's back to our code. We are back in our ID. Now let's look at the other examples. Let me comment this out and let me open the next one. Now what this function is saying, that Spark return me all the job roles which has senior data scientist, along with I am also interested for a specific location of Bangalore. No other locations I am interested in. I am only interested into Bangalore location, and that too role of senior data scientist. If you observe carefully, we have performed an AND operation the exact same way we used to do in our SQLs, where select star or select job roles and location from table whatever it is, where condition job role equal to senior data scientist and location equal to Bangalore, right? Good. Let's execute this and try to see the difference. We have our output ready with us. As you can see now, we have job role specific to senior data scientist and location is very specific to Bangalore. Now let's try to compare both of the execution and try to see the difference. So let me enable the first one where we are specifically looking for job role, where the job role is senior data scientist, and the second execution where we want the senior data scientist along with that the location as in Bangalore. So let me execute this code and we'll see the difference. We have our output ready with us. Now let's compare. In the first execution, let me expand this. Yeah. In the first execution, we have the senior data scientist along with all the companies presented into this CSV file. But for the second execution, we specifically ask that return me the data scientists which are from the location called Bangalore, or where the positions open in the Bangalore location. So now you will be able to understand the difference between row as well as the concept of the filter transformation. We have the same way, we have one more execution where I am specifically saying that location is not equal to Bangalore. See the difference here. We can apply all sort of transformations, all sort of logical implementation here which we used to do in our SQLs. We have the AND operation performed here, and we are saying that I don't really want the senior data scientist, and also I am not looking for the location of Bangalore. And if you execute that, you will get those kind of a result where the job role is not senior data scientist and the location is not Bangalore as well, right? The first piece of code is the transformation, and the chain operation we are performing as an action. In all the case we are doing so. I am specifically doing so to make the code more cleaner. Same way we have some other executions as well. Let me uncomment that and I'll show you. Now in this piece of code, what we are doing, we are trying to multiple values filter in the one condition. We are trying to implement multiple filtrations. Okay, let's say you have an option or you have an need where you need to search all the records which are present for multiple cities. Now here I have created one single list where the list consists of three different cities. One is Bangalore, one is Pune, and one is Mumbai. So I'm creating a list and I'm saying that Spark give me those jobs which are from this list only. Now let's assume a scenario where you wanted to filter out the CSV file. Now your CSV file is very huge in size, and that too you perform a filter operation on multiple conditions where you are specifically saying that let's say you have 30 or 40 locations to scan. In that case, that is not a good idea to rewrite each and every single condition and perform your make your code very lengthy. So in that case, you can create a list out of it and you can simply say that give me those records which are in this list, right? So let's read out the condition. We are saying that data frame dot filter, we are using the column location, and we are saying that locations is in these locations which is Bangalore, Pune and Mumbai, and company is IBM. Show me those records. So I am interested into those records where my company is IBM and that IBM centers are only from Bangalore, Pune and Mumbai. I am not interested in any other location. So if you execute that, code will return you only those records where the company is IBM and the location is Bangalore, Pune and Mumbai, irrespective of the job role. Let's give it a try. For that, let me comment this out, and also let me comment the previous three so that our output don't look so much lengthy. Now here is our output. As you can see, my company is only in the name is only IBM, and as you can see, my location is also Bangalore and Mumbai. As there is a limitation of 20 records by default, Pune may not be included into this list, but I'm sure it must be somewhere down the line. So we are specifically saying that return me only return me only IBM where the location is Bangalore, Mumbai and Pune, and return me all the related data of the company. So this way you can narrow down your implementation and may write much cleaner code. Let's look at the last condition and see how filter works here. We have a like operation as well here, the same way we used to do in our SQLs. So we are saying that give me those locations which are having KO in that location name, and if we execute that, we will see only those records available. Yeah, as you can see, my location is consisting of KO as in keywords. So we have Kochi, Kolkata, Kochi, Kolkata, Kochi, Kolkata, and so on and so forth. Right here you can see Hyderabad, Sikandrabad and Kondapur, where again we have KO. Right. So this way you can apply a filter, a like operation on top of filter. We have covered different varieties of filter operations and tried to understand how data frame can be closely correlated with the database's SQL queries. Same way you can perform so many operations on top of it. I hope by this exercise now you are very much clear with the fundamental of filter operation, transformations and action operations. Do let me know in the comment box if you have any specific question, and I'm happy to help you out. You can check out my Git repository as well to make most of the use of the code which I am demonstrating here. You need to go to CloudGeeks1 repository and then you landed up onto this page. By here you can see multiple code repositories followed into this. If you navigate to the repository section, you will see 9 repositories got created. You can then go to the PySpark examples which I'm right now demonstrating to, and you can clone the repository from this one, where you'll have all the lectures available into this Spark folder where lecture 1, 2, 3 and 4 are demonstrated. Please contribute yourself as well to this repository, and let's help others to understand Spark in more detail. Thank you so much for joining me on this lecture. See you in the next one. Thank you.